Welcome back to our Spark Learning session. Today, we'll be talking about Logistic Regression Consulting project. Let me give you a brief overview about this project. This project is about binary customer churn. A marketing agency has many customers that use your services to produce ads for clients' website. They have noticed that they have quite a bit of churn in clients. They basically randomly assign account managers right now, but want you to create a machine learning model that will help predict which customer will churn so that they can correctly assign customers most at risk to an account manager. Luckily, they have some historical data. Can you help them out? Create a classification algorithm that will help classify whether or not a customer may churn. Then the company can test this against incoming data for future customers to predict which customer will churn and assign them an account manager. So let's get started. Let me start by doing the prep work to start our exercise. Let me import this necessary Spark and create a Spark project. And let me run this. Now, let's proactively import the libraries that we will need for our exercise. PySpark .ml .feature import vector assembler. We will need it later. Let's import PySpark .ml .classification because we'll be classifying, we'll be evaluating using, we'll be classifying using logistic regression for our project. Evaluation, import, binary classification, evaluator. These are the things, libraries we need for our project. Evaluation. Okay. Email evaluation. It is giving me some kind of error here. Let me run this again. Let me do it again. Let me just copy and paste it here so that it won't give me an error. Okay, so let's move on. Moving on to our next step. Let's load the data for our project. Loading input data. The input data should be equal to Spark, and we'll read from a CSV file named customer churn.csv. Customer churn.csv, and we'll infer schema on the read. True. We'll try to understand what schema is it, as well as the header. It is true because this data has some header in it. Now next step is to understand what kind of schema this input data has. The input data dot print schema. Let's see what schema it has. It has names, age, total purchase, account managers, years, number of sites, onboard date, location, company, and churn. We are interested only in numerical data, not string data, because we need to create some vector out of this, and only numerical data will be useful. No, not in string data. Therefore, let's try to check out the data. In our next step, here we need to check out some data. That is, we'll use the describe to understand some statistics about our data. That is, describe show. Let's see what it has. This is our statistics for data, and let's also understand some columns. What kind of columns this data has? Input data dot columns, because it's the same thing. Like understanding the print schema and columns, same thing, but still we'll do the columns. They'll be helpful for us to create a vector assembler later on. We have these columns that we need. Now we need to create a vector assembler. That's why we'll create a variable named assembler, which will be our vector assembler for our purposes. And the input column that we need will be in input columns, and we need a certain set of input columns for our purpose. That is, all numeric columns that we will need for our project, and we'll output this as a features column. Features. Now, what are those numeric columns? Age is one of them, total purchase is one of them, account manager is not, years is one of them, number of site is one of them, onboard date we don't need this, location we don't need this, churn company we don't need this, churn is a label, we don't need this. Therefore, these are the columns we need. Let me format it so that it looks pretty for us. Then let me run this again. Now we have our assembler. Now next step is to take the input data and create a feature vector, append a feature vector on the input data. Now we need to update our input data with a feature vector. Input data with some feature vector equal to assembler, and we'll transform that to add a column of the feature vector to that data. Input data we need to create a separate project for this. Let's say teach, and let's run this again because I suspect it is causing some issue in memory problem. Let's run this again, save this and run this all. Now running it again, it is giving some error here. Why is that? I made some mistake in spelling the transform. Let's run this again. Now it's running. Good. Let's see what's inside this input data feature vector. That is input data dot show. Let's see what kind of data this has. It has names, age, total purchase, account number, years, number of sites, onboard date, location, company, churn, and feature vectors. This is a feature. That's what we just added through our assembler. Moving on, now we'll need to create a separate array that includes the feature matrix as well as a label. That is, we need to select input data feature vector and select columns from out of that. That is, we need to select features and churn, and churn out of that equal to feature matrix with label. Feature matrix label. Then we have the data set we need. Now next step is to divide this data into two sets. One is a training data, one is a test data. Label random split into train and test data, and let's do 70-30% split. And let's deposit them into two variables, LR test and LR train and LR test accordingly. 70% will be train and 30% will be test. Next step, we need to fit it into a model. Before that, we need to define the model. What model we can define? We need to define a logistic training model. Let's do that. Log reg model is that we would need. And logistic regression is what we are using. For label, we'll be using label column, and label column we are using is churn. That's what we are training on. Now we need to train this model on training data. For that, we'll use fitted log model as our fitted log model, and we need to define that on training data. Log reg model dot fit LR train. That's what we need to define on training data. Now once the log reg model is defined, we need to understand a summary out of that. And summary, let's store a summary in a log summary. Let's get a summary out of this data. Let's see what's inside the summary. There are lots of things inside summary, but one thing that we're interested in, predictions. Log summary dot predictions. That's what we're interested in. Prediction dot show. It has a features churn, and it added 3 more columns to that. Raw prediction, probability, and prediction score. Prediction for that. Now let's do one more step. It is an optional step, that is describing log reg summary, prediction. Let's describe that and see what we get. Describe and show. It may give us information that we have not seen earlier. From what we see here is that mean for churn is 0.116 and prediction is 0.012. That means we have lesser number of predictions, true predictions or churn prediction than what actually was, so a little bit less. Next step, we need to run our data set on training data, on testing data. We need to run a model on our test data set to evaluate results. For that, we need to get some result on the test data, getting the prediction on test data. For that, we'll name this as a prediction labels, and we'll use a feature-driven model which we train on training data set and evaluate the test data, LR test. Next step, we need to see what kind of prediction did it show for our test data. Predictions dot show. What is inside this data set? This empty. Why is that? Why LR test is empty? It is empty because we did not put 3 here. So let's run this again. Let's run this again. Let's run this again. Now what we have? Now we have what we need. It's almost a really good prediction, but there are only some minor differences I can see. Next step is to do some evaluation using binary classification evaluator, which we have already defined in earlier step. For this, we'll define the evaluator as bevalrock, and we'll call binary class we initialize binary class evaluator with the raw prediction score prediction column as prediction. Label column as churn. Now we have initialized the binary class evaluator. We need to use this evaluator to get the result what we need. Rock result. Let's name it as such, and we'll call a binary evaluation for ROC, return operating curve. Evaluate the predictions on test result, on test data. Let's do that. Let's see what we get. It is giving some error. Why is that? Let me try to run this again. Because prediction column is incorrect. That's why it is giving me error. Now let me run this again, and let me run this again. Now it runs. Now let's see what result, ROC result we got. It's area under curve 0.769. It's good. Now we need to use the model and train it on the whole data set. and use this model on a new data which doesn't have any labels. Let's do that then. First step, we need to use our model on a whole data set. Fitted reg model will be log reg model we train on a whole data set. Log reg model dot fit, and whole data set is a feature matrix with label. We'll train this on that data set. Next step is to load a new data set that is unlabeled. Unlabeled input data will be spark.read.csv, and its name is CSV. Its name is new customer. Let me copy and paste it from my other slide. New customer inverse schema true. This is our unlabeled input data. Let's see what column does it have. Dot print schema. These are the same columns as we has for our input data. Now we need to create a vector assembler on this data set. Unlabeled input data feature vector, that's what we gonna call it. And assembler will transform this and create this unlabeled input data plus feature vector. That's what we need. And input is an unlabeled input data. Now, next step, we need to see what this data set has. Dot show. This will show me what this data set has. It's the original data plus the feature vectors with the required input columns. Now, let's run this data on this. Let's run our model on this data set. That is prediction label with our results equal to fitted reg model will be our model, and transform. That means it will predict on the unlabeled data. Transform and unlabeled input data. Unlabeled input data feature vector. It will work. It will act on that, and it gives some results. And we have to see that what the result is giving us. Let's see what's inside this result. Dot show. We have our predictions on our data set. It takes feature vector and does some prediction on that. It has created a new column called prediction for our data set. And we see that it is recommending Park Robbins, Sexton Golden, and Baron Robertson be assigned the account managers. And that's exactly what we need. In the end, let me quickly summarize what we did today. We talked about logistic regression model, a consulting project for a marketing firm. It's about customers who tend to churn, and we get to identify customers who are most likely to churn based on some features of the customer, such as age, total purchases, years, number of sites, etc. We use this information to predict the churn on a customer, and as we go on, we have got some information about how this churning will work, and we create a model based upon the training data, and we evaluated the model using testing data, and we got a brand new data set without any labels, and use our model to predict whether a customer will churn or not. So that's all for today. I will see you in the next learning session. Thank you so much.